So we're going to look at some applications of quadratics now, and the quadratic function has some very important applications, one of them being trajectory. Keep in mind, if you were to throw a ball in the air, it would go up, come down in a parabolic curve, which represents a quadratic. And that equation is that the height of that ball, or whatever you're throwing, is equal to negative 4.9, which represents gravity on Earth. This number would change if we were to go to the moon or Mars, plus the velocity at which you throw it up. So this would be the velocity. And then plus the start height. And the start height is how high you started the projectile. So if you're throwing with your hand, it's when it left your hand. All right. And so in this particular problem, Mr. King is 2 meters tall and he's playing catch with his daughters in the backyard, and he throws a football upward with an upward velocity of 8 meters per second. If you take a look at what's happening here, Mr. King being 2 meters tall is simply going to go here. And then the velocity of 8 meters per second will simply go there. And the other pieces really won't change much as long as we stay on Earth. So the equation would still be h of t, representing the height of the object. In flight, basically h of t is this curve. Negative 4.9 again is gravity. It's actually half of gravity on Earth. I'll leave that for your physics teacher to explain. It's actually really well explained in calculus. And then velocity is 8 in this problem because I threw the ball at 8 meters per second. And then my start height is how when I launched it, and 2 meters tall is about 6 feet. And that's how far up it would be thrown from my hand. So once I see those things, I can very easily start to do things like this. When is the maximum height of the ball reached? What is the maximum height of the ball? Well, when is time, and what is height? And it actually says height right there. But they're actually part of the same thing. And in both these things, they're using the word maximum. And maximum is a, when we learned about quadratics, they both know to say maximum. When we learned about quadratics, we learned that maximum was h comma k in vertex form. But if it's not in vertex form, can you imagine trying to complete the square on this? It would be kind of difficult. So the other form of that equation is minus b over 2a comma f of minus b over 2a. You took notes on this back when you did quadratics. We haven't used it. So what we're going to do is we're going to go up here and just label this, A, B, and C. And then what we're going to do from there is we're going to just plug in negative 8 divided by 2 times negative 4.9. You can see that I did that right here on Desmos. It would be very helpful to have a Desmos open so that you can calculate some of these. So if you want to pause the video and open a Desmos to get that value, go ahead. Okay, so once you find that value, what happens is you now need to find, and that is the answer actually to this question. What time would that happen? The time would be, the when is going to be this first value, right? It's going to be 0.816 seconds because that's the input. Remember, we talked a lot about inputs and outputs. And in this equation here, the input value for the entire problem is time. And so when you think about the fact that this right here is an input, then that's going to give you time at the end. Well, the output value is height. And so that's going to give you the other part of the problem. And to do that, you put the input into the function. So, just make sure you understand that when you do that, when you do that on Desmos, just use parentheses appropriately. So like our function is negative 4.9, and then we had 0.816. I just need to make sure I'm putting that in parentheses and that I'm squaring it appropriately, and I'm taking my time using parentheses, using the same number, and just, be careful. Like for instance, you got to put an 8 in front of that parentheses, right? And so just be careful with what you're doing. Make sure you're not making typos, and you can see you get 5.265, which I have a screenshot of there, and that is the answer to that. So basically, when we're looking at this dot right here, this thing happens at 0.816. That's the time. That's how long time has elapsed. But the height that is here is 5.625 meters. Now, where did I get the units from? They're actually in the problem. And units are very important when you do word problems. Notice that you have the word meters per second right there. You have the word meters there so that you can figure out what units would be. So here's another side of the equation, which is when would the ball hit the ground? Effectively, that is asking for the same thing as the x-intercept, because if you go back up here and look at the graph, basically that is eventually going to come here and intersect that, and that would be the x-intercept. It would be 0 and then some x value, but in this case it would be some t value. So when I ask when does something hit the ground, I'm asking you to set the problem equal to 0, right? Set the problem equal to 0. Oops, I labeled that backwards, my apologies. So the x-intercept, of course, is x and 0, so we need to find t comma 0. So we're looking for an output value that is 0. So that just means set the problem equal to 0 and use the quadratic formula, which we've done many times, but I'm going to show you how to do it on Desmos. I think it will be helpful to learn how to do something like this on Desmos. And what we're going to do is we're going to do baby programming, a little bit of maybe call it pseudocode. And the way you do this is, you have A, B, and C, and Desmos is capable of you just plugging that in. A equals negative 4.9, enter, B equals 8, and C equals 2. And you can literally just type the quadratic formula in here. You can just say, hey, the quadratic formula is minus B plus square root is in here. It's in the keyboard, square root of B squared minus 4AC. And then remember, you have to highlight the whole thing and divide by 2a, and it'll give you the first answer. And that being said, you might say, well, what about the minus? There is no plus or minus anywhere in the keyboard. You cannot put it in. So to do the minus, you just copy this whole thing, hit Control-C or right-click and hit copy, however you do it, and then paste, and then change it to a minus, and that'll give you the negative, okay? So I have that all nicely screenshotted right here. And notice that I've crossed this one out because in every problem, not just this problem about quadratics, every problem, if they're talking about time, there's a domain restriction that time must be greater than 0. And that's not the case for everything. Velocity actually can be negative because it just means it's moving left or possibly moving down. It just changes direction. But time has to be positive. So we crossed this one out, meaning the ball hit the ground at 1.853 seconds. All right. So the next problem that we have here is, well, what would happen if the ball reached 4 meters? Now, to explain what's going on there, if I were to look at this and I were to put this here, 4 meters is here, right? And so they want to know these 2 points of intersection. And you can do it with a graph, but we might as well just use the quadratic formula since we already have it in our, again, that would look like that, set the problem equal to 4. We might as well use the quadratic formula because we already have it in Desmos. We did it right over here. And all we have to do is remember that the quadratic formula has to be set equal to 0 no matter what the problem says. So this 4 equals this curve is exactly what you're seeing here. You see a curve. We're looking for these 2 dots where it equals 4. So mathematically, that's what we need. But quadratic formula wise, I need to set it equal to 0 by subtracting 4 and then plug those in. All right, so let's see here. So I'm going to plug these numbers in. These are my new A, B, and C. Now, that being said, if this is my new A, B, and C, my A and my B are the same. So the only thing I have to update is my C value. So if I go back into Desmos, all I have to do is go over here and say, hey, I solved it, and now it's -2. Again, if you look at it, when I subtracted 4 on both sides, my C is now -2, and it will automatically update my values to accommodate this new problem, which I have screenshotted here. Now, both these work because they're both positive, all right? And what's going to happen is that I'm just going to say that the ball reaches 4 meters at this height, at these times at this many seconds and this many seconds. And it's important to write that out so you can understand what's happening and that you get used to writing word problems out with a sentence. Now, again, why are there 2? Well, there's 2 explanations. You can see the visual right here. It goes up and hits 4 meters and then comes down and hit 4 meters. But as long as this question here is asking for a number below the vertex, the answer would always be 2. And this goes back to when we learned about quadratics and we did the discriminant. We had 0, 1, or 2 answers. If I asked you when was the ball going to hit 5.265, you would say 1. You'd already know it because you did this. But what if I changed this problem and I said, when would it hit 6 meters? Well, 6 meters is above the vertex. So when will the ball hit 6 meters? The answer is never. And the reason that happens is because you would have an imaginary discriminant, and in Desmos, it would say undefined. If you're using like a TI calculator, it actually would say unreal result. All right, so a quick review. When you do trajectory, you use this equation if you're doing metric. If you do English standard units, it actually changes this number a little bit. And to find the vertex, you're going to find the maximum or minimum, which we used to call HK, but there's this other way to do it if you can't complete the square, where you do minus b over 2a, and then you do f of minus b over 2a, which means plug it in. And that's going to find the time and the height. And then if you ever have to solve something, you could graph it, but I showed you, because we're doing quadratics, how to use the quadratic formula. All right, I hope this was helpful.